Derivatives of sine and cosine functions. So the goals here, want to know the derivative of the sine function, know the derivative of the cosine function. Believe it or not, with just those two, you can build up all the rest. You know, the tangent, cotangent, secant, cosecant. As long as you know the sine and cosine, you can do all the rest. So let's go ahead and take a look at the derivative of the sine. And we're going to look at this graphically first, get a sense of what the derivative might be by estimating its graph using the graph of the sine function. So if I'm doing a derivative graph from an original function's graph, first thing I want to look for, are there any horizontal tangent lines, places where the slope is 0, where my derivative value would be 0? And I see that at pi over 2, so I'll put a dot at pi over 2 and 0 on the derivative graph, and then 3 pi over 2 as well has that horizontal tangent line. So 2 places, here and here. All right, now I'm going to look at 0 and see if I can get an estimate of the slope, and it kind of looks like the slope there is 1, so I'm going to put that right there. At pi, it kind of looks like the slope might be -1, so I'm going to put a dot there. And then at 2 pi, it looks like it's a slope of 1, so I'm going to put a dot there. And if I were to connect them right now, I get like a V-shape, absolute value. I can tell you for certain the derivative of the sine is not the absolute value function. So there's got to be more going on in between these dots. And you could spend a lot of time drawing tangent lines and, you know, counting slopes of those and plotting them. But I'm going to kind of take more of a, just kind of estimating approach. And when I look at the graph of the sine between 0 and pi over 2, it seems like the slope kind of stays close to 1 for quite a bit, and then you get out maybe pi over 4 and it really starts tailoring off and getting smaller slope values, reducing down to 0. So I'm going to draw this kind of like where, it stay closer to 1 for a bit, and then it really starts tailoring off there and tailing off down to that 0 slope. And then after that, between pi over 2 and pi, kind of a similar thing except in reverse. So it's going to change pretty quick there for a bit, and then maybe kind of just get close to 1 or -1, and not really take maybe that much time, but it's it seems like it drops down pretty quick and then gets that -1 or close to it, and then gets to exactly -1. Now coming out of pi over to 3 pi over 2, it's a similar type of shape. So I'm going to see something that's maybe similar, maybe a symmetry here coming out like that, and then using again symmetry coming out like this. And again, you could spend more time doing this, but just kind of rough estimate here. When I look at this result now, I'm like, that kind of looks like a cosine graph. It's not perfect by any means, and my drawing skills in this tablet are not great, but it does kind of look like maybe a cosine. So the hypothesis here is that the derivative of the sine is the cosine, which is crazy, but let's see if that actually holds true when we use the definition of a derivative to find the answer. So if we set this up, we'll have the limit as h goes to 0, and we'll have the sine of x plus h minus the sine of x all over h. And right here we got to split up that sine of x plus h. This is a sum of two angles in the sine. There's a sum formula, an identity for the sine of a sum. And if you use that identity, you're going to get the sine, and actually we'll have this limit out here. Sorry about that. Make sure we get that in play. Carried away. So we'll have the sine of x times the cosine of h plus the sine of h times the cosine of x, and then minus that sine of x still that was there originally, and then all over h. So the sum formula for the sine, expanded that, and now moving to the next step, what I want to do is start grouping some like terms together. After that expansion, there's some terms that have the sine of x in them. In fact, it would be this first one and the last one. So I'm going to factor out the common sine of x, and that'll leave me with cosine of h and then minus 1 in the parentheses. And then we'll have plus the sine of h cosine of x still there, that middle term, so to speak, that didn't have anything common to factor out. with that all over h. And then the next thing I want to do is start splitting this up. I want to break it into multiple limits so that I can start looking at pieces here individually. Using our limit laws, we can do this. So I'm going to have the limit h goes to 0 of the sine of x, and I have a common denominator of h, so I'm going to split this sum up, this first term plus the second in the numerator over a common h. So each fraction I'm going to create here is going to get that denominator of h. And then I'm going to add to that the limit now, and separating the limits here, as I said. And then I'm going to have the cosine of x. I'm going to switch the order on that second term. And then I'm going to put the sine of h over h. So we're getting to a place here where I can start thinking about evaluating the limit. And the sine of x on the first limit doesn't have an h in it. It's technically a constant relative to this limit operation. So I'm going to go ahead and bring the sine of x out front. And then I'll have this limit as h goes to 0 of this cosine of h minus 1 all over h. And this thing's being a little slow, so let's try that again. There we go. And then similar thing on the next one. Cosine of x doesn't have an h in it, so that's technically a constant relative to that limit operation. So I'm going to go ahead and just bring that out front. And then we got the sine of h over h. So for these two limits now, I'm going to use a graphic approach to see what they are. There's other ways to do this. I think graphically you're going to see the result. It'll be fine. We're looking for essentially this cosine of h minus 1 over h as h goes to 0, and then the sine of h over h as h goes to 0. And again, there's multiple ways to do this. If you were to search ways to find the limit of these two things, there's algebraic approaches, geometric approaches, there's a lot of different approaches. But I think the graphic approach, just seeing what it goes to, is going to be totally fine for this and help us get to the end. So let's go ahead and look at a graph here. And I have the cosine of x minus 1 over x. I can't use the h here in this graphing software that I'm using. And I want to see what's happening to the graph as I get close to 0, as the x, in this case replacing the h, goes to 0. And from both sides, looks like I'm going to 0. Okay, so that's good. So I'm going to go back over here to the notes and I'm going to start getting this going here. So I'm going to have the sine of x, and then that limit of that cosine of h minus 1 over h as h goes to 0. Looks like it just goes to 0. And then we'll have cosine of x here. And let's see what that sine of h over h looks like as we go to 0. So I'm going to turn that one off and turn that one on. And it looks like it's going to 1. So, and in fact, if you were to use all the other, more involved approaches to finding this limit, you would see, yeah, it goes to 1. So, the graphing is giving us the good result. So I'm going to just put a 1 here. And lo and behold, sine of x times 0 is 0. Cosine of x times 1 is cosine of x. And wow, yeah, so through all that process, we can see here that the derivative of the sine of x is actually equal to the cosine of x. Crazy, but true, and something you should know. All right, so let's move over here then to the cosine and look at that. So first thing again, I'm going to look at the graph and see if we can get an idea of what its derivative might be. And cosine of x graph I have here, the derivative ready. And again, I'm going to look for horizontal tangent lines. So there's one here at 0, one at pi, one at 2 pi. So I'm going to have a 0 here, here, and here. Looks like I have a -1 slope at pi over 2, so it'll be down here. +1 slope at 3 pi over 2, so I'll have that up there. And I'm not going to connect these and make some jagged, straight line thing. It's going to be similar to what we saw when we were doing the sine one. So it's gonna come out of there pretty fast and decrease pretty fast and then get to that -1. So it's gonna be something like this, and then come back up something like that, and then go over something like this, and then come back down something like that. And when I look at this, it's like, oh, that looks kind of familiar. You know, if I look back even at this first page, it looks kind of familiar to the sine, but it's like, instead of going up from 0, I go down. And that's, you know, everything else looks good. So really what this looks like is a reflected over the x-axis sine graph, which would actually just be the negative sine of x. So my hypothesis then is that the derivative of the cosine is actually the negative sine of x. So again, let's go ahead and see what happens with the definition of the derivative. So I'm going to have the, oops, if this thing will stay where I want it, there we go. We'll have the limit as h goes to 0 of the cosine of x plus h minus the cosine of x all over h. And I'm also going to use the sum formula for the cosine, using that identity from trigonometry, and it ends up being the cosine of x times the cosine of h minus the sine of x times the sine of h, and then minus the cosine of x still out here hanging out in the back all over h. And again, I want to start factoring some things. I look here, I see a cosine x here, cosine x out here. So I'm going to factor out a cosine of x, still have a limit statement. And oops, this thing's being a little slow. So I'll have the, wow, that's going crazy there. Technology, right? Okay, so, wow, what's going on? It's just doing some weird stuff here. I'm going to have to pause this video for a second. Okay, so I got the pen work again, but let's fill this in. So you got the 0 here. We'll factor out that cosine of x, and then we'll have the cosine of h minus 1, and then we're going to have minus the sine of x, sine of h, all over h. And from here, I'm going to split things up in a similar way to what I did before. So if I do that, I'm going to have this cosine of x out front. I'll have the limit as h goes to 0 of the cosine of h minus 1 all over h, and then minus the sine of x times this limit as h goes to 0 of sine of h over h. So splitting up similar to what I did for the sine one on the prior page. And what I get here then, I have similar things for the limits. We already saw the limit as that h goes to 0 of cosine of h minus 1 over h is just 0. And we already saw that the limit of sine of h over h as h goes to 0 was 1. And whoa, lo and behold, there we go, the negative sine of x coming right out of there. So, in fact, the derivative of the cosine of x with respect to x is equal to the negative sine of x. All right, thank you for watching.